Hey everyone, thanks for joining. My name is Shovik. I'm a product manager here at Amazon S3. So we're going to talk about Amazon S3 Lifecycle today. And S3 Lifecycle is my favorite product within Amazon. One of the reasons is I'm a product manager for Lifecycle, so I kind of get paid to say that. But also, my goal for you guys today is when you're done with the session, I'm going to be talking about some tools and giving you some ideas that will help you reduce your storage spend immediately after. So that's my goal today. So if I'm unable to do that, I've failed this session. So hopefully not. So today we're going to talk about a lot of our new storage classes, and we're going to talk about the portfolio of S3 storage classes. I'm going to give you a really quick intro into what Lifecycle is, what it's designed for, what it does. And then I'm going to talk a little bit more around archiving workloads. So we will see how Amazon S3 really helps you save cost when you move your objects from storage class to more archival type storage classes. So we'll talk about that. We'll also then talk about versioning and controlling versions with S3 Lifecycle. And then finally, we'll talk about taking actions on lifecycle action. So we'll look at a really cool media and entertainment use case and tell you what you can do with lifecycle actions with event notifications. And then finally, we're going to touch on some best practices. But before we get into lifecycle, I want to talk a little bit about Amazon S3 storage classes. So Amazon S3 has many different storage classes for your many different workloads. For example, we have S3 Intelligent Tiering, S3 Standard, all the way to S3 Glacier Deep Archive for your own storage needs, depending on whether you need millisecond access or for your more archival, rare access workloads. So I want to start by talking about S3 Intelligent Tiering. So S3 Intelligent Tiering is the only storage class in the cloud that delivers automatic storage savings based on your access patterns. So when you have objects within S3 Intelligent Tiering, it automatically tracks your last access for those objects and sends to infrequent access tiers and archive instant access tiers to give you storage savings when you don't need instant access for your objects. This is ideal for data lake workloads with unpredictable access patterns, where you don't really know how hot or cold your objects are going to be. So S3 Intelligent Tiering takes care of that for you. And as we talk to more customers, we see S3 Intelligent Tiering becoming the real default for our data lake use cases. For more predictable workloads, we recommend a host of different storage classes and S3 Lifecycle to optimize your storage cost. We start with S3 Standard, which is our default storage class. When your objects get older and you think they won't be accessed as often, you can move them with S3 Lifecycle to S3 Standard infrequent access. Earlier this week, we launched a new storage class. We are calling it S3 Glacier Instant Retrieval. This storage class is ideal for your objects that you can save storage cost on, but that you only need to access maybe once or twice in the year. So think about your archival workloads that you access rarely, but when you access them, you need them in millisecond access. So S3 Glacier Instant Retrieval is really cool for those media workloads, archive workloads that needs millisecond access. And when you're OK getting access from minutes to hours, S3 Glacier Flexible Retrieval, which is the new name for S3 Glacier, by the way, and S3 Glacier Deep Archive are ideal archival storage classes for those kind of archival workloads. And finally, we have two specific storage classes for specialized workloads. The first one is S3 One Zone IA for easily recreatable data or for storing data in a separate region for separate copies. And we also have S3 on Outposts, which is our on-prem S3 storage solution that works with the same S3 APIs. So now that you have a basic understanding of S3 storage classes, I want to go through two different ways of managing the storage lifecycle of your data. The first one is with S3 Lifecycle, where you set up your own DIY lifecycle policies for moving your objects from S3 Standard all the way to S3 Glacier Deep Archive, depending on what your workload needs. The second one is using S3 Intelligent Tiering that does this tiering for you based on last access patterns. So today I want to talk specifically about S3 Lifecycle. So S3 Lifecycle gives you two types of action. The first one is transition action, where you can define when your objects need to move from S3 standard or other storage classes to more cost-efficient storage classes. The second action that S3 Lifecycle does for you is expiration actions, where you can then define when objects are deleted when you no longer need them. And S3 Lifecycle does that based on the age of your objects or when new versions are created. And I'll get to versioning in just a bit. So as you can see in this waterfall, you can send objects from storage class A to storage class B as long as storage class B is a more cost-efficient storage class. And you can set rules based on age and number of versions. I'm going to give you 5 seconds to quickly look at the diagram, and then I'm going to move on. All right. So moving on to S3 Lifecycle, I want to first talk a little bit more about what you need to do before you set up your lifecycle policy. We believe in an insights to action flywheel, which means first you gather insights and analytics about your data, which then influences the right lifecycle policy that you want to set up for your bucket. And we offer two unique analytics tools for you to do exactly that. The first one, we call it S3 Storage Lens, which we launched last year. And the second one is S3 Storage Class Analysis, which has been here for a while. Quick show of hands, have any of you used or familiar with S3 Storage Lens? OK, I see a few hands here and there. Cool. So S3 Storage Lens is becoming really, really close to my favorite product. And one of the reasons is it is so rich in data that tells you so much more about your storage. So S3 Storage Lens helps you answer questions such as, which one of my buckets are growing the fastest? What is my non-current version distribution? What are some of the data protection policies that I should apply? And Storage Lens is really ideal for that. So we had a ton of Storage Lens-specific sessions here at reInvent. So I'm going to show you some of the advanced Storage Lens metrics that you should use to influence your lifecycle policies. The first one is the bucket and organization and account snapshot. So Storage Lens works in the AWS organization level, which is our highest level in hierarchy, all the way to account level, bucket level, and even in the level of prefix. So as you can see on this slide, Storage Lens is telling me I have 17 different accounts taking over 32 terabytes of storage with over 17 buckets. So this one just gives me a quick snapshot of where my storage lies. Looking at a little bit of a more advanced metric, this one gives me a bubble chart on average object size and how often do I retrieve objects from these buckets. And automatically, Storage Lens tells you that the buckets with higher sizes but with lower retrieval rates are really good for those lifecycle policies. So this kind of metric really helps me then decode what is the best lifecycle policy for me. And you can create a host of different types of bubble charts for your own analytics tools. This one's one of my favorite because retrieval is so related to how hot or cold my buckets have become. So using information from here across my buckets, I can then identify a couple of buckets that I want to analyze and dive deep a little bit more. So I use the storage class analysis tool, which is bucket specific, that then tells me more information about the access and usage pattern for each of my bucket. Using storage class analysis, I can get recommendation on how many days should I wait before sending my objects from S3 standard to S3 standard infrequent access. Once I get some of those information and I feel comfortable in creating the lifecycle policy that I need for my bucket, I can then go to my bucket configuration and then set up a lifecycle rule. It's pretty simple. You go to your bucket configuration page, you go to the management tab in the console, and you set up your lifecycle policy. I'll get into nitty-gritties and details of different knobs and buttons in the lifecycle configuration in just a bit, but here I'm just trying to give you an overview of what is the workflow for setting up lifecycle for your buckets. So for example, in this one, I've created a lifecycle policy that transition objects to the standard IEA storage class after 30 days. So when my objects become 30 days old, lifecycle automatically transitions them into the standard infrequent access storage class. And then I can similarly set up policies for my non-current versions as well. I'll get to versioning in just a second. But here, I can optimize my storage, and I don't pay higher prices for objects that I don't need as often. Creating lifecycle policies is pretty simple. I can create a transition policy and an expiration policy within the same rule. So for example, I can create within a rule to move my objects to standard infrequent access after 30 days and move them to Glacier Deep Archive after when they have become more than a year old. So general overview, cool. I want to talk a little bit more about details of a lifecycle configuration. So a lifecycle configuration is a collection of rules, and each rule has 4 distinct elements. The first one is an ID, which uniquely identifies your lifecycle rule. So for example, if you want to audit all of your lifecycle rules, or if you want to change a specific rule, rule ID can really help you gather which rules you need to change, by what, and keep a track of your lifecycle rules. Second is lifecycle rule filters. So often customers tell us that they want to apply a lifecycle policy across their entire bucket. But often we hear from data lake workloads and other analytical workloads that buckets have several hundreds or thousands of prefixes, each with a specific retention policy. So with filters, you can create a lifecycle configuration that applies only to a specific prefix or even object tags. Object tags are customized metadata that you can have for your objects, which is a key value pair for specific retention policy or for access controls. Object tags work really well with lifecycle policies, where you can create really granular lifecycle filters so that objects in your entire bucket is not under the lifecycle policy, but only a subset of that bucket is. Then we have status. You have the option to enable or disable a lifecycle rule. For example, let's say you're testing out different rules. So you disable a rule, you enable another one, and really figure out what's working the best for your storage cost optimization. And finally, we have actions. Actions, I think, is the most important part of the rule. This is where you define where the subset of your bucket is moving or when you are removing those objects. And we'll get into details of each of this in the next slides. So I want to start off with the filters first. So as I mentioned, you can filter by your object prefixes. For example, let's say you have a bucket and you have multiple prefixes and you have objects for each of this prefix, right? So if you create a lifecycle policy that only acts on objects in prefix A, you can do that by applying a filter in your lifecycle configuration. Similarly, you can use object tags to tag objects across different prefixes for your lifecycle policies if your objects have similar retention needs but are not under the same prefix. You can also combine prefixes and object tags to find ANDed conditions when objects are in a specific prefix and also has a specific tag associated with it. And finally, we launched this last week, where we are adding new object size filters to lifecycle configurations. I'll get to why this is super important in just a bit. But just to give you an overview of object size filters, you can now set lifecycle policies for objects if they're greater than a specific size, if they're less than a specific size, or even if they're within a range of 2 size threshold bounds. This is really, really helpful for archiving storage. But before getting into all of that, I want to talk a little bit about the economics of what happens when you archive or transition objects to the Glacier Flexible or Glacier Deep Archive storage classes. So when you move objects, for example, from S3 Standard to S3 Glacier Deep Archive, you are saving your monthly storage cost by over 95%. This is great. Your monthly storage spend reduces by a lot, because you don't need instant access to those objects. You barely retrieve them. So this works out really well for you to reduce your storage spend over time. However, transitioning objects from S3 Standard to S3 Glacier Deep Archive also means you're paying a per object transition cost. So to optimize your storage spend even further, we want to make sure that we only send the objects to S3 Glacier Deep Archive or S3 Glacier Flexible that makes the most sense and that optimizes the most cost for you. So when we think about archiving storage, these are the two costs that you should think about. First one is the one-time lifecycle transition cost that you pay upfront, and second, by how much your monthly storage spend is reduced by moving these objects to Glacier Flexible or Glacier Deep archives. Using these two costs, you can define your own payback period. For example, let's say I'm sending 10 objects from Standard to Glacier Deep Archive, and I'm paying a lifecycle transition cost upfront. How long does my object need to live within Glacier Deep Archive for me to be able to break even on the lifecycle transition cost? So we did some analysis, and I want to share some of my findings with you. So in a 2x2, in the y-axis, I want to talk about retention period, which is the total lifetime of that object within S3. How long does the object live within this archive storage class? And on the x-axis, I want to think about the size of the object. And I want to see which of these use cases are ideal for transitioning to Glacier Flexible or Glacier Deep Archive. So the first one that I want to see is the bottom left quadrant, where the object size is really small, but also they live for a very short period of time. These objects are not good for Glacier Flexible or Glacier Deep Archive. The reason is that when you have several thousands or millions or even billions of tiny objects, moving all of them to a Glacier Deep Archive, for example, would mean that you're paying a one-time transition cost that is on a per object basis. So the one-time transition cost is high. And then the second one that I mentioned, your lowered monthly storage, that's also not enough because your retention period is low. So you're not storing those objects for a very long time. So this is not a good candidate for archiving. The second use case is when your object size is still pretty small, but the retention period is higher. For example, a lot of logs that you use later for analytics. But even if the retention period is high, we see when the object sizes are really small, we are talking about a ton of batches of objects, which makes it less likely for you to be able to save on storage in the total cost of ownership point of view when you transition them to Glacier Deep Archive. Then we look at the final two, which is higher object sizes but different retention periods. For higher object sizes, but for lower retention period, we think it could be really helpful, but you have to do a little bit of further study into what your retention period really is. But when your objects are bigger and you want to retain them for longer, they are the best candidates for transitioning or archiving to Glacier Flexible Retrieval or Glacier Deep Archive. And this is why we build the object size filter, because customers tell us that this is absolutely the right way to do things, but right now, since we don't have an object size filter, we can't really easily transition objects, so they had to do a lot of analysis on their back end, maybe run inventory report, tag objects retroactively. So we wanted to short circuit all of that and give customers a very easy way to build in object size within their lifecycle policies. Now, at this point, you might be thinking, Shouvik, okay, this is great, I understand it, but I have so many buckets, so many objects. Like, how do I know what is my size, what is my distribution, what's my retention? So for that, we go back to Storage Lens and see another bubble chart that I've created for you as an example. So here, what I'm tracking is average object size across my different buckets, the number of objects within these buckets, and also the total storage for these buckets. So as you can see here, there are some buckets that I have that have a really high average object size. So these become really good candidates for transitioning to Glacier Deep Archive or Glacier Flexible, as long as you don't need immediate access on a very frequent basis. And you also see objects, you also see buckets with much lower average object size that you can then exclude from your lifecycle transitions. Does that make sense? So using this information, you can identify the buckets that you need and then create lifecycle policies to archive those objects before sending them to Glacier Deep Archive. So I feel I've talked a lot about high-level terms like object size, retrieval patterns, and all of that stuff, is I wanted to show you a real example of a typical use case bucket that we see. So here we have a bucket with a lot of small objects, many medium-sized objects, and a few large objects. Well, in S3 scale, a few means hundreds of thousands. So for this bucket, when I transition all of these objects from S3 standard to S3 Glacier Deep Archive, I see that it needs a minimum of 15 months of retention period for me to be able to break even on my one-time transition cost. This would mean those objects need to sit in S3 Glacier Deep Archive for at least 15 months for that to make cost sense. And this is a good reality for many of our customers, because often they have objects that have compliance statuses that need to stay on for years, and over years, you're eventually ending up saving a lot more money. But if your objects are short-lived, maybe less than 15 months, maybe 6 months, or maybe 9 months, this may not be the best way to transition and archive your objects. So with object size filter, you can exclude the smallest objects. And you can only transition the medium-sized and the large-sized objects. That reduces your payback period by a lot. So instead of having to wait for 15 months to be cost positive, now those objects only need to sit in S3 Glacier Deep Archive for 4 months. And you can do this by using the object size filter. Going one step further, if I exclude the small and the medium-sized objects, you can see that my payback period gets even lower. So this is the most efficient way to optimize your cost when you're archiving your data that you don't need as often. Cool. So it's clear that object size filter is going to be very helpful in saving you money, right? So now you must be thinking, OK, how do I set it up? So we have made the setup process as easy as possible. So object size filter will work just as easily as other filters in the lifecycle policy. So you have filters such as prefixes. You have filters such as tags. Object size will be a new filter that will work in conjunction with them. So for example, in this one, I have set a floor of 128 kilobytes and set a ceiling of 5 gigabytes. Within the console, you'd be able to use different size units that works for you. So with this lifecycle policy, the objects that are going to be transitioned or expired will live in that size bound, higher than 128 kilobytes, but less than 5 gigabytes. Object size filter will also work in conjunction with prefixes and tags. For example, if you have different retention policies across your different prefixes, or if you use object tags as your way to create new lifecycle policies, you can add that with object size filter. For example, you can set up a rule so that object size filter and a prefix work together to create even more granular lifecycle rules. Cool. So we talked about archiving storage. We talked about object size filter. So I want to make sure that I give you a few key takeaways. The first step for you is to determine the object size that work best for your workloads. And the way to get that information is using S3 storage lengths that gives you average object size distribution across all of your buckets in your accounts, or across multiple buckets across your accounts, right? So that way you can generate data such as average object size across your different buckets to identify the right candidates for archiving. Then you can use the object size filter within S3 Lifecycle to maximize your storage cost optimization. And finally, once you have created the object size filter, you can choose to transition larger objects to Glacier Deep Archive and keep your smaller objects in standard or standard infrequent access. So if you had to ask me for a cheat code, and if you say that, hey, Shovik, like, I understand that I have to look at storage lengths, I have to look at object size, and I have to look at all that, but can you just give me a cheat code that I can then apply to my buckets and just be happy? I will tell you, if you have objects that are going to Glacier Deep Archive or Glacier Flexible Retrieval, setting up a default for 128 kilobytes as a minimum object size is going to immediately save you money, because objects under that size will just keep racking up the lifecycle transition costs. So if I wanted to give you one next step for you today, is to go to your bucket, and if you see a lifecycle transition policy to Glacier or Deep Archive, I want you to turn on the object size filter for minimum object size at least 128 kilobytes, or a little bit more if you'd like to save even more money. Cool. So next, we want to talk a little bit more about versioned workloads. So does anybody use S3 versioning at all for their buckets? Quick show of hands. OK, ton of hands. So a lot of us use S3 versioning, are familiar with versioning. But I see a few folks who don't use versioning. So I'll give you a really quick intro to S3 versioning and what it does. So S3 versions is a bucket-level construct where you can enable versioning for your bucket. Once you have enabled versioning, it offers you protections against accidental deletes or accidental overwrites on an object level. For example, let's say I have these 3 objects in that bucket, just for simplicity. And let's say I deleted one of those objects by mistake. I issued a delete API call without the version ID. What S3 would do is, instead of actually deleting that data, it would create a delete marker on top of that object. Now, the delete marker doesn't have any data associated with it. It just tells S3 that this object has been deleted with a delete API request. And then, when you try to issue a get object to that object, it would return a 404 error. However, there is a way to delete specific versions as well. If you issue a delete API call with the version ID, S3 would just remove that version. So that's basically how versioning works on a very simple scale. But things can get really complicated for complicated workloads. For example, let's say you have data lake workloads or analytical workloads where you create an override data every single second. So we hear a lot of our customers that generate thousands or tens of thousands of overrides every single day, and that becomes an everyday reality for their workloads. So often we hear that non-current versions keep getting accumulated, and then they need a way to figure out how to optimize for cost and not have to pay extra storage for all of these non-current versions. So in this example, with constant overrides every single second, I'm generating versions across the board and they get older. So one of the ways we are able to control versions is with Lifecycle. And one of the ways we generate insights and gain more visibility into our non-current versions is with S3 Storage Lens. So for example, in this storage lens bubble chart, I have created 3 different variables to analyze. The first one is the total non-current version bytes. The second one is the percentage of non-current version bytes with respect to my total storage. And the third one is average object size. So this bubble chart tells you that, hey, for these buckets, you have a lot of non-current versions. You have a ton of non-current versions in terms of objects, and you also have a ton of non-current versions in terms of bytes. So what this insight tells me to do is to go create a lifecycle policy to be able to control these non-current versions. And now you must be thinking, OK, I have different workloads, and I don't want to change my application to reduce my versioning. So we offer customers lifecycle policies to do exactly that. So with Lifecycle, you can control your non-current versions so that your non-current versions don't accumulate as they get older. For example, in this Lifecycle policy, I have created a non-current version expiration condition. This means after 5 days of being non-current, Lifecycle will automatically delete a non-current version. So in the previous graph that you saw, as non-current versions get older, which means the number of days they have been non-current, Lifecycle would automatically delete them. In this case, Lifecycle will automatically delete non-current versions as soon as they become non-current for more than 5 days. So what does that look like in my same workload? So you'll see here that without making any change in the application, right? So I'm still overwriting as much as I did nothing changed in my override behavior. But as a result of that lifecycle policy, I now have much fewer non-current versions than I did in the past. And as a result, I'm saving on storage. So I still have the non-current versions that I need that are less than 5 days old in case I want to roll back. I still have non-current versions that are more recent, but as soon as the non-current versions get older than 5 days, I can remove them automatically with Lifecycle. But we wanted to give you even more granular tools to control your non-current version actions. For example, customers often tell us that, hey, this is working really well for me. I'm able to control my non-current versions, but it would be great if I could control non-current versions on numbers instead of days. So we decided to give exactly that. Now, we launched this earlier last week, that you would be able to create non-current versions, not just based on age, but also based on the number of non-current versions created. For example, in this policy, you can create a lifecycle policy that will retain the non-current versions that you need. In this one, I have chosen to retain 3 non-current versions. That's my rollback that I need. That's all the data protection that I need for my application. So I will have 3 latest non-current versions at all times. And any non-current versions beyond the 3 non-current versions that I'm keeping, as soon as they become older than just 1 day, S3 Lifecycle would remove them. And that 1 day is also customizable. So you can play around depending on your data retention and data protection needs to identify the best lifecycle policies for you. So if I apply this lifecycle policy without making any change to my application, what will that look like? So as you can see, the overwrite rates remain the same. There has been no change to my lifecycle policies at all, but my non-current version stack has reduced by a lot. I'm only keeping 3 non-current versions, and as soon as they get older by more than a day, I am removing them. All right, so I also wanted to give you a cheat code. I gave you a cheat code for object size filter where I told you that, hey, if you don't want to do any of that analytics and just set up a quick filter that immediately saves you money, use 128 kilobytes, right? Now, if you come and tell me that, hey, Shovik, I understand that I have to go to storage lengths, I have to look at my non-current versions, but just give me the ideal. Let's just give me something that works. What I would tell you to do is keep a few versions for your rollback. Keep 3 or 5 versions, depending on what your applications need. And then remove the older ones faster, after 1 day or 2 days of being non-current. As a result, you will see immediate cost savings to your storage bill, and then you can then identify with storage lengths to create more granular non-current version policies. I'm going to pause to grab some water. So in summary, with non-current versions, you can first start with S3 storage lengths. With S3 storage lengths, you can take a look at the total non-current bytes. You can also take a look at the percentage of non-current bytes with respect to your total storage. You can also triangulate that data to the total storage across your different buckets to really see the cost impact of these lifecycle policies across your buckets. And then, once you have identified the right strategy, you can then create S3 lifecycle rules to make sure that you're removing or transitioning versions. By the way, non-current version doesn't always need to be expired. You can also choose to transition non-current versions to more cost-efficient storage classes. Let's say you want to retain the non-current versions for compliance, or you want to take a look at them later or access them later for machine learning or analytics, but you don't need them immediately, so you want to just store them, for example, in Glacier Instant Retrieval, our new storage class. You can set up non-current version transition policies for lifecycle as well. All right, so Next, I want to talk about something that we also launched very recently on the first day of reInvent on Monday. So customers often tell us that, hey, I need more visibility to what happens to my objects. Customers use S3 event notifications to take actions based on object changes and changes made to S3 objects with S3 APIs. But customers often also tell us that, hey, when Lifecycle transitions my objects or removes my objects, I want to keep a note of that. Maybe I want to track it in a Dynamo table. Maybe I want to keep a track of it in my media asset manager. So we are giving them exactly that. So now you can set up S3 event notifications to lifecycle actions. So for example, when lifecycle transitions an object to a cost-efficient storage class, you can use event notification to be notified when that happens in real time. Similarly, when lifecycle expires an object and you want to update a secondary index or a metadata table that your object no longer sits in S3, you can do that by also setting up an S3 event notification. Now you might be asking, like, okay, why is this important though? Like, what's the deal here? Why do I need to do this? So to explain that, I will walk you through a media and entertainment use case. So a lot of our media and entertainment customers have tape libraries that they want to onboard to Amazon S3. When they do that, they have a lot of ingest of media assets. Think about large video files, large images that they need to broadcast or stream on the day-to-day basis. Often what happens is media archives get really, really big. For example, you have video files all the way in the 1990s that you sometimes need to broadcast on an immediate basis. Now, customers like to store them in our archive storage classes. Let's say they want to store them in Glacier Deep Archive because they are big files, they are prime for those storage classes, and they only need them when they need them, which is once a year or maybe even less. So what happens is they use lifecycle policy to move these objects to S3 Glacier Deep Archive, but they don't often know when they need them. For example, sometimes in an emergency sometimes in news broadcast, you have to get highlights or reels from video footages that happened 2 decades ago. So then what they do is they want to access that file, but because they're sitting in S3 Glacier Deep Archive, it's not available for immediate access. So then they issue an expedited request to make sure that they retrieve the file and then from S3 standard. So they issue that restore copy. Once that restore sits in S3 standard, they get an event notification. So they know that the restore is now available for instant access. Once they receive that event, then they play that file for broadcast or streaming straight from S3 standard. Now, this is great, and this works well, but often customers with several thousands of or millions of archives with lifecycle policies don't often know whether their objects are in an archival storage class like Glacier Flexible or Glacier Deep Archive, or whether they're in S3 standard when they don't need to issue a restore at all. So often, to navigate around that problem, they do daily polling or weekly polling to check whether objects are in standard or whether objects are in more archival storage classes. They do that by issuing head API calls or using S3 inventory to know where objects are in their storage classes. So now, with S3 Lifecycle notifications, every single time an object gets archived or object transitions to a different storage class, or objects are deleted, they would be able to send that notification to Amazon SNS topics, SQS queues, invoke a Lambda function, or even use Amazon Event Bridge, which is our new destination for Amazon S3 event notifications. With those event notifications, you can always have a running record of where your objects exactly are so that you are aware of whether you need to issue a restore or whether you can directly get that object from an instant access storage class. All right, so we talked a lot about different things that we have built this year for Lifecycle. We first talked about the object size filter, which then helps you understand how archiving objects work for optimizing your cost. It helps you set up lifecycle policies to make sure that you're getting the maximum storage savings by transitioning your higher-sized objects to Glacier Deep Archive or Glacier Flexible. Then we talked about versioning control that helps you control the number of versions that you have and the storage price that you pay for them. And finally, we talked about S3 Lifecycle event notification that gives you more visibility to your lifecycle actions. So at this point, you must be thinking, OK, a ton of new stuff for lifecycle. Can it also get my coffee? I mean, I would say the team is working on that, but I also want to share a few quick best practices on what S3 Lifecycle can do. Often, customers upload their objects by issuing a multi-part upload request, by adding different smaller-sized objects into a larger batch. When these multi-part doesn't finish or doesn't complete, these incomplete uploads stay in your S3 buckets. Lifecycle helps you removing these orphaned uploads, and Storage Lens helps you get more visibility. For example, I can check how many incomplete MPUs I have across my different buckets and use Lifecycle to expire them and immediately save on storage. This is the same thing for expired delete markers as well. An expired delete marker, as I mentioned in my versioning slides, is a delete marker that has no non-current versions or data associated with it. So it's literally just a delete marker with no data in the background. Storage Lens can also give you more visibility into how many MPUs or expired delete markers you have, so that you can then use lifecycle policies to remove these multi-part uploads and these delete markers from your buckets instantly. For example, you can set up a delete multi-part after 7 days of creation. So after 7 days of your complete multi-part, if your request has not completed, S3 would remove those incomplete MPUs. Now, once you have set up these policies with the console or with the API, you can actually go back to Storage Lens to see if those policies took the intended effect. So as you can see in Storage Lens, after creating these, my storage usage for MPUs and expired delete markers drops significantly immediately. So this is an easy fix to save on storage on day one. Awesome. So we talked a lot about new lifecycle stuff, and I'm really happy to answer some questions. So I want to spend the next 10, 15 minutes to get some questions from the audience. And I will also be available after the session if you have more specific questions. So does anybody have any questions? Yeah, please. Yeah, that's a great question. So Storage Lens has 2 tiers. So we have the free tier Storage Lens, and you have the paid tier Storage Lens. With the free tier Storage Lens, you can have a lot of metrics without having to pay for anything. So you can get metrics for your buckets. You can get metrics for your accounts for free, no charge. Storage Lens also has an advanced tier where you pay per object scanned. So you can turn on that advanced tier to get a lot of advanced metrics, like some of the bubble charts that I showed in the slides, and only pay for what you use. One of the ways customers love to use Storage Lens is by turning on that advanced tier for a day, using that analytics, and then turning it off, and then maybe turning it on after a week, and then checking those analytics, and then turning it off again. So you can use Storage Lens advanced tier based on your needs, based on how often you want to analyze your storage. Does that answer your question? Sure. Yeah. Yes, so you were asking whether the bubble charts that I showed in the graph, do they show up in Storage Lens? Absolutely. So those are taken from real Storage Lens dashboards from my own buckets, right? So Storage Lens, the beauty of Storage Lens is you can create the dashboard that you want. So there's a lot of default dashboards that are given to you that you can then analyze for high-level views, granular views, but you can also create dashboards based on your own storage needs. So for those, I created my own dashboards to check my non-current version storage, to check my object size across my buckets, and you can do the same thing. You can also create dashboards for encryption status. You can also create dashboards for MPUs. So the world is your oyster. You can create the dashboard that you need within StorageLens. Can you download the dashboard? Absolutely. You can download the dashboard. You can export the dashboard for your own individual analysis as well, for sure. Any other? There's a lot of lights. I might not be able to see. Ah, there you go. Yeah. So you're saying, is there a recommended time to use for non-current versions? Yeah, I think that's a great question. So I would say a big part of that will depend on your use case, right? But in terms of a best practice, I would use the number of non-current days in conjunction with number of non-current versions to retain. So if you retain 5 or 10 versions, for example, and then transition older ones after 3 or 4 days, you will always have those 10 non-current versions to go back to. So even if you're deleting your older ones too early, you always have latest non-current versions that you have specified available to you. And then I would also take a look at your StorageLens dashboard to see how often you are using your non-current versions before setting up more granular policies. Thanks for the question. Any other questions that I can help? Yeah. Based on days and not retention rates. So if you have a bucket, so understanding your question, so you're saying that lifecycle is based on the age of the object, right? So can I, oh, rate of access. Okay, that's a really good question. So if I understand the question right, so lifecycle acts on how old the objects are and whether new versions get created on the object. You're asking, why can't I create a lifecycle rule based on access? Is that right? Yeah, I think that's a really good question. And we think that the ideal way for access-based lifecycle is within our intelligent tiering storage class. So within S3 intelligent tiering, which, by the way, you can modify your put APIs, for example, to directly add objects to intelligent tiering. So you don't really have to life cycle to intelligent tiering. So when objects are in intelligent tiering, for a small monitoring and automation fee, it automatically tiers your objects based on access, right? So it automatically will tier your object to the infrequent access tier if it sees 30 days of no access, right? And yesterday, we launched the S3 Glacier Instant Retrieval, which is our new storage class. And we also added the S3 Glacier Instant Access tier within intelligent tiering. So after 30 days of no access, objects would move to the infrequent access tier within intelligent tiering. And after 90 days of no access, they would automatically move to the archive instant access tier. So as a result, if you have objects in intelligent tiering, and let's say you haven't used them for 90 days, and they're sitting in the infrequent access tier, when you go back and check, now they will move to the archive instant access tier. So without doing anything, you would have saved a lot more money. Does that make sense? For sure. Did I miss anybody else's question here? Yeah, absolutely. Yeah, so you're trying to understand what are some of the use cases for customers for S3 event notifications. So customers often build event-driven applications that react to changes within their S3 objects. For example, you can think of adding a video file to an S3 object and then running a Lambda function that acts on that video file. Maybe you want to transcode that video, maybe you want to transcribe that video, do some machine learning on the video. And the easiest and the best way to do that is to set up an S3 event notification. So when you add that video file, if you have configured that event notification so that when objects get added to S3, it automatically invokes a Lambda function to do whatever you have coded that Lambda for. So for example, resizing images is a really popular use case. Redacting personally identifiable information, that's a cool use case as well. And you can also set up event notification based on different filters. So you have filters based on prefix of the object, suffix of the object, to do customized actions based on your S3 object changes. Does that make sense? Cool. So any other question that I can help with? Awesome. Thank you so much for joining us today. I had a lot of fun talking about Lifecycle. Please don't forget to complete the session survey. And yeah, thanks so much for joining, and I hope you have a great last day of reInvent.